Welcome to the webinar, Mango Flowering at High Temperatures, Tools and Mitigation. My name is Cesar Favero. I am the Industry Relations Manager, and I will be the moderator for this webinar. I would like to now present our speaker, Dr. María Hilda Pérez Barraza. She is an agronomist from the University of Juárez in the state of Durango. She studied at the master's and doctorate level in the Fruit Cultivation Center of the Postgraduate College at Montesillo in the state of Mexico. She's been a researcher for INIFAP from March of 1982 until July of 2024. She worked with the Tropical Fruit Research Program of INIFAP in the Santiago experimental field in Nayarit. Her lines of research in mangoes were reproductive physiology, use of bioregulators of growth, and orchard management. She participated within INIFAP in the coordination and participation of a series of research projects supported by private companies and the National Mango Board. She was awarded the Fruit Production Award by the Postgraduate College in 2023. She also won the Nayarit Medal in Scientific and Technological Investigation in 2017 and 2019. She is currently an independent consultant, and she works as a speaker in different events organized by scientific associations at the national and international level, as well as extension meetings for the National Mango Board. She is also the president of the scientific committee of the 14th International Mango Symposium that will take place in Mazatlan, Sinaloa, Mexico, from May 28th to 31st of 2025. Welcome, Dr. María Hilda Pérez Barraza. Thank you very much, Cesar. Good afternoon to everyone. It's really a great honor for me to be here, and I would like to thank the National Mango Board for allowing me to participate in this very important webinar series. This afternoon, we're going to talk to you about mango flowering at low temperatures and tools and strategies for adaptation and mitigation. This issue came about due to an in-depth review of flowering. Why flowering? Because it is really the most important process in mango production so that we can produce fruit. But what do we need for this? Well, we need shoots, we need plant growth, and it must reach physiological maturity so that it can move to the reproductive phase and produce flowers and fruit. So this is true of all mango varieties and all growing regions, and it varies depending on the weather and the variety and the environment. However, in Mexico, all of the varieties that are grown have seen changes in these phenological stages, primarily in flowering. Why is this? Well, without a doubt, climate vulnerability is one of the main problems. And this is attributed, or this can explain the reduction in production in the four varieties produced in Mexico. And what happens is that during the fall, when flowers should be formed, the low temperatures and high humidity in the soil leads to irregular flowering and a reduction in export volume. When we see that the flowering should be taking place, if we see low temperatures and high humidity, we see very low yield because flowering is irregular. However, in this situation, production of the four varieties see an increase later on in production, a reduction in prices. This has not been seen only in Mexico, but it's also been seen in other growing countries such as Peru and Guatemala. And this has led to serious losses, up to 50% or more in production, according to the data of the National Mango Board. Peru saw a reduction in its export volume of 36% and in between 2023 and 2024. Why was this? Well, precisely due to high temperatures which affected flowering. So why are we interested in reviewing this issue? Well, of course, we can't change the climate, but I do think we can study how we can mitigate the effects. So the objective of gathering all of this information and to study this issue is to understand if the lack of cold temperatures is the only factor that determines flowering in mangoes, and also to determine what physiological, biochemical, and molecular factors are related to heat stress and flowering. Also, to identify this information and strategies to determine and to look at what has been done throughout the world, and also to determine new research lines of research to identify methods of adaptation. So, what has been done? Well, we focused on gathering scientific information internationally and also in Mexico, also interviews with growers in Mexico and others in the industry regarding flowering and flowering induction. Also, there's a large database of articles, and we focused on this number of articles because due to their relevance. And also, these issues are related to the different stages in flowering, such as plant growth, which is necessary to produce flowers, then the flowering process, the factors that affect flowering, focusing on high temperatures, the techniques used to ensure or modify flowering, which really is what growers are most concerned about. They want to make sure that their trees will flower. And what do we propose? What can we do to adapt mango trees and mitigate the effects of high temperatures? The first issue is plant growth. Why plant growth? This growth establishes the quantity of fruit that will be produced on the tree. We need shoots and we need buds and we need them to flower in order to produce fruit. What affects this process? Well, temperatures, because the shoots and the buds depend on the environment. Mangoes are a tropical, subtropical product, and they need temperatures between 20 and 35 degrees Celsius. That's optimum. It needs humidity over 70% and precipitation over 1,000 millimeters. So the genetics of the varieties also affects flowering. We have more and less vigorous varieties, and also the rootstock effects of the variety affects the type of growth and the type of flowering. In terms of the endogenous conditions within the trees, we have the availability of carbohydrates and hormones such as gibberellins, which leads to vegetative growth or plant growth. And then we have field practices. We know that pruning leads to growth, as well as watering, irrigation, and fertilization. Proper fertilization leads to vegetative growth, particularly nitrogenated fertilizers. So, what happens if these conditions are prolonged? Then the growth will be excessive. The vegetative growth will be very vigorous and excessive. It will be extended during long periods of time. And so the flowering and the fruiting may be affected. So, what do we need? We need shoots, shoots that have to be of a certain age to flower. Immature shoots or buds will not flower. So the age, the physiological age is important so that it may be induced. And we're talking about 3 to 6 months, which also depends on the environment where the crop is produced. So we have shoots of different ages, but they have to be physiologically mature because mature shoots receive the environmental stimulation that is necessary for flowering. This stimulation is received in the leaves of the mature shoots. So we are also talking about the strategies to achieve this maturation, such as potassium sulfate sprays, ethifon, and others. Well, ethifon is a synthetic growth regulator that stimulates ethylene synthesis. And we know this is a maturation hormone. So this helps us to mature the shoot, but we have to apply it at the right time. Potassium sulfate has also been widely used to promote maturation. It has been used in different varieties. Normally, ethylene is used at 1,000 milligrams per liter, and potassium sodium at between 2 and 2.5%. These biostimulants are products that are also used and that improve certain processes in the plant, including tolerance to heat stress. So these are products that have been produced based on bacteria, algae, proteins, and other elements. Many are available in the market, and generally speaking, they make photosynthesis more efficient because the plant life depends on photosynthesis in general. And the application of biostimulants can also have an effect on chlorophylls and carbohydrates, which are also necessary for proper flowering.
This is a list of the papers that were reviewed, and I wanted to share with you one of them. Let's take a look. Those applications for shoot maturation happen after applying fertilization, which will promote vegetative growth, and then it promotes maturation with the techniques that I just mentioned. One of the works that only applies bacroburazole, it has a good percentage of shoots with flowers, around 80%, but if later on they also apply ethylene or ethifol, and then the percentage will increase. That means that it will produce more flowers. So we have a lot of papers that show that the application of etherphone or even potassium sulfate can help with the maturation process, and it can also increase the induction capacity. Now, when we reviewed vegetative growth, we understood that it's needed for the trees to have mature shoots so that they can flower in the future. It will depend on the variety, and it can be between 3 to 6 months. Now, once we have the vegetative shoots, we will start in the flowering process. So now we already have a place for flowering. Now, what is flowering? We need to understand the process, because flowering, it's not only to see flowers in the tree. It's not only about it didn't flower or it did flower. We need to understand the process from before the bud starts to lead the way for flowers. So flowering involves several phases, starting with the transformation from a vegetative bud that will create leaves, and then there is a reproduction phase that will lead into the flowering stage. This transition from the vegetative stage to the production stage has three very important processes: induction, initiation, and floral differentiation. First of all, we need induction when the signal is captured in the leaves, and then they send the signal so that this important process of initiation can start. It will, where the bud will become a flower. Later on, once there is a full bloom, flowering is when we see the flowers in the trees. Now, what are the factors involved in flowering? We have very old models by doctors where shoot initiation, which means a mature shoot that can be inducted towards a reproductive or a vegetative shoot, It's a very complex process. As you can see in this graph, you can see that there are several circumstances, both internal and external to the plant, and it's very complex because flowering it is complex. But we can summarize more or less the process in the following terms. If we want the meristem or the bud to flower, if we need first vegetative growth. And how can we achieve that? It depends on the crops that we had on the previous year. If it was very abundant, it means that we might have a good crop as well because there is excessive fertilization, and also humidity will play a role, as well as precipitation, irrigation, warm temperatures, and certain hormones such as gibberellins. Gibberellins can be a vegetative promoter, and also certain genes that will act as repressors for flowering. How can we achieve a bud that will eventually flower? Well, we need to have moderate pruning. We need to have adequate fertilization. We don't want to apply nitrates when we are close to flowering. It is said also that drought can help for bud differentiation, as well as the photoperiod. But I think that this relates more to annual species. I think that mango does not respond too much to photoperiods. But there are some studies that we can review a little bit later that show that mangoes can respond to that as well. We also need light so that we can have a differentiation. So those farms that are in shade will not be interesting for a good flowering. Cold temperatures, this is apparently the most important factor, and certain hormones such as the cytokinins and genes that will induce flowering. This is all very important for flowering. There are two very important factors from an endogenic point of view, which are hormones and carbohydrates for bud differentiation. There are a lot of different hormones, and we know that within flowering, it is very important the function of gibberellins and cytokinins. When we have GAs in a high content compared to CKs, we will see flowering inhibition. And here, as you can see, we have a vegetative promoter that is boosted by GAs, and we now know that it's a gene. But now when this situation changes and GAs are not as high as CKs, then we will promote flowering, and this goes hand in hand with carbohydrates. Here we see that we have flowering promoters, and we know through molecular studies which are those factors. There have been a lot of studies performed in different varieties with a regular production, and all the physiological studies that have been performed have proven that there is a high content of hormones such as CKs, ABAs, GAs, and salicylic acid. And with a high content of carbohydrates, which helps for varieties that do not alternate compared to other varieties that do alternate every year. Now, sugars and a lot of carbohydrates. It's very important to have availability of starch as well as saccharose to improve flowering. Sucrose is very important, and it acts from the leaves. The leaves will receive the stimuli, and the presence of sugar will improve the creation of a gene that will be translated into proteins and that will be sent to the bud to start flowering. Here we have another very important sugar, which is T6P, which will activate, or rather will help to activate other genes that will identify the meristem as a reproductive organ, and it will be able to boost flowering. So we need carbohydrates as well as sucrose to induce flowering. Here, I would like to show you several studies that were performed about what happens with the different hormones. And here we can see that there are studies on certain parts of the plant, and when there is an induction with high cytokinins, etc. And these studies already mentioned the application of cytokinins, for instance, in the Tommy Atkins mango production, and we have seen positive results in their flowering processes, also the application of sugars. With this review, we have learned that in order to have favorable induction, in order to have a good differentiation process, we need carbohydrates, and we also need hormones such as the cytokinins, which is what most studies are focusing on. But I would like to remind you to my last slide, because these are not the only hormones that come into play. We have other hormones such as the jasmonic acid or salicylic acid that have not been studied yet. So potentially we could find other solutions. But for now, we know that cytokinins as well as gibberellins for inhibition, and we have also seen that we have very interesting candidates in starch and sucrose for differentiation. There are other studies which are much more basic. These are molecular studies. In the past, there was very little work done in mangoes. But with climate change, we have seen that mango has been vulnerable to high temperature, to other stressors such as floodings or disease, etc. And now we have seen that it's different to decipher molecular mechanisms to understand the response of plants, mango plants, to stress and the effects on the flowering transition. There is a plant, Arabidopsis thaliana, which is an annual, very small plant. We have been able to discover the whole genome of this plant. And I saw these numbers. I saw that they had identified to 27,000 genes that were codified for protein. And the function of over 70% of these genes is already known, including the flowering genes. So these studies on the Arabidopsis were very important to compare with other fruit trees such as mango, avocado, citrus, grapes. The first research was performed by a Japanese group that was able to discover that the gene, the MIFT gene, which is similar to the Arabidopsis, is expressed in mature leaves in trees when they are exposed to low temperatures. The conclusion was that MIFT is a signal for mango flowering. It would be our aim, what we're looking for. And this was very important. Here in Mexico, we applied this study on the molecular studies of our varieties, and we saw how in shoots that were located in different positions in the trees, depending on the orientation of each tree. And the biggest expression of this gene that will create the flowering was obtained, as you can see in this red line. And this was related to the shoots that were oriented towards the sun, towards the east. As you probably have seen, the trees will initiate flowering in the site where they are exposed to the sun. We also studied, or let me first tell you that the biggest expression happened in this type of buds and also during the month where temperatures were low. We also connected this with the application of inhibitors such as PCA or PBZ and comparing to shoots that were not subjected to this treatment. And we saw that the largest expression was in the shoots that had PCA and then number two with PBZ. And in the normal shoots, the gene was not expressed almost, and with the application of gibberellins, it was not expressed at all. What does this mean? That the inhibitors also were expressed during the coldest months here in Mexico. So that means that MIFT is the gene for the signal for flowering in mangoes, and it is regulated by temperature as well as by regulators that can inhibit gibberellins. And we were able to corroborate that gibberellins block the expression of the gene and they inhibit flowering. Now, this is all very important information that we need to have, but I believe that we need to have even more information. We have seen that research performed both in India and China have been studying this part of molecular biology, and the most studied gene has been MIFT, which leads to flowering, and it's expressed in mature leaves. They have also studied other genes located in the meristem where flowering occurs, and they have found that there is a lot of genes involved that can identify the meristem not only in the vegetative stage but also in the reproduction stage. And some research says that this happens during the flowering process. And they have summarized that flower induction is involved in two different gene categories, which are very similar to the Arabidopsis. The first gene family is those genes that integrate the flowering signals so that the leaf can capture this signal. And then the second family uh, involves genes that identify the meristem. The meristem is identified, and here there are other families of genes involved to identify meristem in the reproduction form so that they can go through the flowering process.
But how are they expressed or how are they related? What promotes expression? Well, at least it is known that certain gibberellin inhibitors, such as PBC and peroxidone, promote expression. Cool temperatures, light, certain hormones, such as cytocyanides, and there have been studies as well in this regard, metabolism of carbohydrates, and certain other organic compounds, such as phenylpropanoids, and that this is in addition to hormones. And at what level of expression? Well, gibberellins inhibit the expression of the flowering gene, but they promote genes that suppress flowering. Lack of light also inhibits expression. So we should not shade the orchards. Also, a high fruit load promotes flower repression. So it's a very complex process. And now this is the model for mangoes. This is from Dr. Davenport. This is much more complex, and this is from a point of view of molecular biology. And then we have Arabidopsis thaliana, and it has different pathways for flowering, 5 pathways, and it only needs one to flower. There we have the gibberellin pathway, and so we see flowering with gibberellins, which we don't see with mangoes. It's much more simple, but look at the mango plant, mango tree. It is much more complex. We have environment, temperature, the age of the shoot, and all of these come together. All of these factors come together to promote, to induce the gene or to inhibit the gene. But there are some similarities. There's the hormonal path as well. And so this depends on the quantity of hormones, which may promote or inhibit FT, and also carbohydrates, sugars, primarily sucrose and others. And generally, these promote FT gene expression. All of the pathways, such as in Arabidopsis, occur at the level of the leaves. All of this has to take place in order to generate the gene that will lead to flowering. It must then be transported to the meristem and for it to be identified as reproductive and to in fact lead to flowering. So this is very complex, yes, extremely complex. It is regulated by a genetic network that includes different exogenous signals, temperatures, water stress, age of the shoots. And we're not just talking about one of these, but it requires all of these. And in addition, there's an endogenous network, such as hormones, carbohydrates, and other metabolic pathways, which is maybe the key, really, to achieve that so desired stimulation for adaptation. So now we're going to talk about temperature. What effect does temperature have on flowering? Well, we need cool temperatures for flowering in the subtropics. And in the tropics, it has more to do with the age of the shoots because we might not have these temperatures. But we have also seen that we need at nighttime temperatures under 20 degrees and 3 to 6 months in terms of shoot age in order to capture the signal and transmit this signal to cause flowering. And then if we have warm temperatures above 30 degrees during the day or 20 at night, then that will result in more vegetative growth and immature shoots, and this will not promote flowering. So in tropical conditions, we talk about not just 15 or 10 degrees. It's not a recipe. It depends on the variety as well. What temperatures the variety will need, daytime temperatures and nighttime temperatures. In terms of tropical conditions, cold temperatures may be erratic or there may not be cold temperatures. So the shoot age there is very important to achieve differentiation. If we do not have these factors, then we will see problems. Many studies indicate that this difference is due, above all, to the environment where mangoes are being grown and the different varieties. And there are even some varieties that flower in areas where they do not have cold temperatures. We have some Indian varieties that flower practically year round. So depending on the environment, there are different temperature ranges from 15 to 28 degrees during the day and 10 to under 20 at night. So the presence of temperatures over 20 at night and over 30 during the day have a negative effect on flowering. And so we see very irregular flowering by stages. Sometimes it can be very erratic. We can see a reduction in flowering or even complete absence of flowering, at least in Mexico. The Kent variety sometimes does not flower at all. And so this causes extreme losses in terms of fruit production and export volume. In Nayarit, this situation was seen for the first time in 2009. And at that time, we thought this was an atypical event, a one-off, but then we have seen this again in future years due to climate change. So We see irregular flowering due to temperatures, low flowering, and sometimes no flowering at all. And this has occurred now several times repeatedly over the years. So here we have a summary of the research studies that we reviewed in order to determine what conditions are propitious. So cool temperatures in the tropics can help in the subtropics in these ranges, which are different depending on the variety and the location. And in the tropics must be at least 32 during the day and under 20 degrees at night during the induction period or the flowering or the flower differentiation period, so that there will be adequate flowering, which is necessary to produce fruit, of course. So plants are stressed by high temperatures, and they often do not flower. There are different types of stress, of course, drought, flood, rain, insects, but we are most interested in stress due to high temperatures. Well, high temperatures are good when they're within the optimal range to produce vegetative growth. But what happens if temperatures are above this optimal range? We will see excessive vegetative growth, and this will affect flowering. So these periods of high temperature lead to heat stress within the plant. And what does this mean? Well, we see an elevation of the temperatures during the day and at night. And if this continues for a period of time, it can cause irreversible damage in the plant. So what is the physiological basis? Well, the first thing is we see a reduction in the efficiency of photosynthesis. Photosynthesis really is necessary for flowering, development, growth, fruiting, production, survival itself. So what happens if we see a reduction in photosynthesis? We see an increase in the respiratory rate. We also see deactivation of an important enzyme called rubisco, because this enzyme is really key for the for CO2 fixing. And we also see a reduction in redox potential. What does this mean? These are chemical reactions that lead to the transfer of electrons. Why is this important? Well, because during photosynthesis, this transfer is extremely important so that the final product is sugars which support growth, production, and even the survival of the plant. So if photosynthesis is affected, basically it affects the entire functioning of the plant. So we see also problems with carbohydrate production, which affects other issues, fruit development. Fruit drop as well might be increased. We also see hormonal imbalance, and also hormones can lead to vegetative growth. We also see imbalance of secondary metabolites that have to do with a lot of the plant's functions. We also see an increase in the amount of ROS at high temperatures. What is ROS? It is oxidative stress. And this means that within the plants during photosynthesis, there's a balance in terms of oxygen regulation. Regulation is produced and released, but when the plant is stressed by high temperatures, this affects the stomas, and we see an increase in the amount of oxygen, and this oxygen becomes dangerous. It's toxic for plants. So we see damage to membranes, proteins, DNA, and this also will harm floral differentiation, which is what of it is interest to us. But if this happens during fruit development, it can lead to fruit drop, it can hamper fruit growth, etc. It can cause a great deal of damage. So what can we do to prevent this type of damage? We have seen gibberellin inhibitors, nitrates, management practices, and biostimulants. In terms of gibberellin inhibitors, we have paclobutrazol, which is the most widely used product, among other triazoles, and then we have uniconazole. This is used in mangoes, also in avocados and other products. We also have seen some research with metaconazole. It hasn't been used too much in mango or studied too much in mangoes, but we have this other category, which is more environmentally friendly. There's been very little research in mangoes. These have been used in certain fruit products as well as grains. So here we have a summary of different research studies in different areas. And this is just a small sampling with different ages and different areas. And in the majority of cases, they're using paclobutrazol. The best results have been seen applying paclobutrazol to the soil, not to the foliage. They're seeing positive results with vegetative growth, moving up and increasing flowering, as well as yield with different varieties. However, something that's very important is that this will only work with effective orchard management. Without effective orchard management, really, PBZ will not work.
It can also be perceived as a potential polluter, both for soil, and it could also create some damage on human health. However, it could be like a pilot for strategy for certain places, such as Brazil, where induction temperatures uh, are hardly ever under 20 degrees at night. So they have to use this product in order to promote flowering. In Mexico, we have also used PVZ during those years where conditions were not conducive for flowering. We have used that product and it helped us to increase even the number of differentiated buds at around 50%, as well as with the use of PCA, which helps, but as you can see in the second year, we found that using PVZ, we had an improvement almost at 80% compared to when we didn't apply it. But as you can see, we have never achieved 100% of the shoots ready for flowering. So when this happens, this means that we need to work a little bit more on this type of research. Now, moving on to what type of remedies have been used, we can see that we have done research with different inhibitors. However, in Mexico, we don't have a lot of studies. There have been studies performed in Brazil, in India, on several varieties. However, we still need to determine the doses. For instance, in Australia, there is a study that says that maybe CCC can be useful. However, we don't know how much of it to use it. So more research is needed in order to find out about that. In Mexico, we have started the research with PVZ. And then after a few years of studying PVZ, with several doses, with several number of applications, we reached the conclusion that there is a specific doses that could equal PCA and PVZ. Even with the use of PCA, we could improve production over PVZ. And with these results using PCA and adding other types of inhibitors, we found that we can improve both differentiation as well as flowering and yield comparing to the control group. And For instance, we saw that with PCA 1500, it could improve the results with PVZ. So we believe that for us, PCA could substitute PVZ. However, we need to do more research in order to have better results. Now, biostimulants have also been used. However, what they do is that they help for shoot maturation, but they don't really, the research doesn't really prove that they stimulate flowering. And we have performed studies in areas such as Brazil, and it's used for shoot maturation so that we can have higher possibilities of having more shoots that can flower in the future. There is only one study performed with the Tommy Atkins variety that states that in warm climates, the application of this bioproduct, which are algae, 60 days after the application of PVC, promoted a uniform flowering. However, in most of the cases, they do not report flowering. However, uh, they do create a better quality of the fruit. Now, for management techniques, we need to talk about water stress as well as pruning and bending. There are a lot of research studies that have proven that low temperatures are very important. In terms of pruning, we don't have favorable results that will say that pruning will be inducive of flowering. However, it is important because it synchronizes the age of the shoot. I need to induce my 80% or 90% of the shoots, because if I don't prune, then I will have different shoots on different ages, and induction will happen on different periods, on different phases, depending on the age. There are research papers that say that pruning helps to delay flowering, and also a specific type of pruning, if we use it at the specific dates close to flowering, it can improve the differentiation of buds. We can have, instead of just one bud, two or three. Now, this point here is very important. We need to know exactly when we need to perform pruning, because we need to know when the bud will start flowering to perform the pruning. Otherwise, we're going to interrupt the vegetative growth. And now, bending is not a very common practice in mango. It's used mainly for lychee, and it helps flowering. However, we don't have a lot of research performed in mango, and I think that it would be very interesting to explore this area. Now, forced production in mango has four basic steps. What do we need? We need to promote vegetative growth through pruning and fertilization. Now I already have my shoots, so I can interrupt or stop using less water and without the application of nitrate fertilization. This will help us to discontinue or stop the growth, and then we move on to maturing the vegetative shoots, and then finally we have induction, which would be to break the buds so that we can have a better flowering. Now, it looks very easy. However, it's not that easy. This is something that works for Brazil, for instance, but it doesn't work for Mexico. It doesn't work in tropical areas where, when we need to reduce water irrigation, we are in a raining season. It's very hard. It's a big challenge during raining periods to force that flowering. It can be done, but not at 100%. And I think that we need to keep working on this phase. Now, after all of the review that we've done, what can we do? What are we lacking? And this is my opinion after I was able to review all the research that has been done so far. Now, for high temperature stress, I think that we need to deepen in the physiological studies to generate knowledge on the damage created by high temperatures. We need to understand what happens in the trees. We need to make a germplasm selection, and we need to generate varieties that can be more adaptable, that can face climate change, specifically high temperatures or even droughts. I think that in every region we have an interest in germplasm because there are germplasms that will flower even though the conditions are not great. Now we have to do a characterization of our climate areas, how climate affects it, and we also need to do a characterization of the requirements of the cultivars that we already have or for new varieties so that we can have knowledge on the areas that I can harvest those plants. It's not about just generating new varieties, it's about knowing what we need in certain locations. This way, the new farms will be established in the places where there is enough cold temperatures. Now, practices to lower temperatures. We don't do that in mangoes. We have seen that we use shading, we use cooling with irrigation or application of cold to the soil. This happens in pear trees, in avocado trees, but this is something that we have not explored in mangoes, and we could do some research on that. To generate basic knowledge on the hormonal effect on flowering, we have worked a little bit with cytokinins, but there are other hormones that could be explored. So what happens if we combine two of them, or what is the function of each of them in induction? This is something that we need to explore. And why not? To keep validating and generating technologies to reduce excessive vegetative growth and to promote shoot maturation, where we have in areas where we have quite a bit of precipitation. We also need to explore the relationship with reserve carbohydrates and especially their interaction with hormones, because as I told you before, this is a very important aspect with starch, with sucrose. We need to do more research on that to see what type of combinations can help us with flowering. Now, moving on the molecular biology, I think that there are a lot of studies that are currently being carried out about uh, the definition of the functions of genes, but they are not being studied in the interaction with environmental factors. I think that we need also comparative transcriptomic studies, which are very complex, but there are certain people who could perform them. And I think that we should not only stay at the genetic stage, but that we should also perform metabolomic analysis so that we can identify which metabolites are involved in the flowering process and the role that they play in its regulation. I believe that if we do that, if we succeed, and if we can identify the compounds, then we could potentially incorporate that into our management practices so that we could facilitate flower induction. We need to work on integral flowering models, on the molecular marker development. We are already working on this area. We need to identify molecular markers associated with flowering intensity because there are a lot of varieties that flower without the help of temperature. What are their genes? There are certain varieties that require less cold temperatures for their flowering stage. So potentially we could create varieties with a greater number of promoter genes, and we could also create varieties that can be more resistant or that can be more adaptable to a high environmental stress. In every region, there are several interest varieties, and we need to study them because in India, in China, in Japan, they are studying their varieties, and I think that we should do the same. And above all, we need to have an integral model, a comprehensive model. I don't think that we need to work in silos. We have our field researchers, right? People who know about the fields. We also have the genetic professionals. We also have people who are experts on biomolecular biology. We also have physiologists, etc. Different professionals who are working now independently, and this is not going to work. We need a comprehensive model, and of course, we are also facing a common enemy, which is very important for us, which is the climate. And I believe that if we integrate everybody, if we can have an interdisciplinary group, we will be able to develop models that will help flowering in different locations where mangoes are being harvested so that we can have better flowering year after year. Thank you so much for your attention. Thank you, Dr. María. Hilda, we have now some time left for a couple of questions. The first question that I have here in the chat is the following. In high temperatures, the large amount of oxygen created in the photosynthesis process can affect the quality of the fruit, and what happens during that process? Are you talking about the fruit when it's already harvested? Yes. Well, this would have to do with post-harvesting management, and yes, it could be damaged. Those fruits which are already harvested, I understand that they are talking about the treatment, and we have to see to what extent they can resist this type of temperatures. Now, if the fruit is still in the tree, high temperature will affect the tree not only about flowering, but also if the fruit can stay to the tree and how the development of this fruit will be once it's harvested. Well, this is what you got in on your field, and it will depend on your post-harvesting practices in order to conserve the quality that we found on the field. And yes, high temperatures can affect the fruit, of course. If you harvest mangoes during when there's sunshine, it will reduce their quality.
Another question from Giorgio, can sucrose be applied to the leaves to generate flowering? Well, I think that's a very interesting question. And there is a study that indicates that they are applying triisophosphate. This has been done with paclobutrazol nitrates. And really, this is a big question that we haven't explored. We really should look into this. And there are some products that are supposed to reduce the ROS effects, oxidative stress effects that can help plants to regulate temperature stress. These products have not been used in mangoes, but I do think there are some other products that could be studied, and why not sugars, application of sugars. There's a very interesting question here from Felipe Varela. Thank you, Felipe. If I have a mature shoot almost ready to flower and it rains, say 60 millimeters of rains, and then the shoots become vegetative growth, what can I do to promote new flowering? Well, this is really part of our focus. This happens that right when we're at the point of flowering, it rains. Well, what you have to do is eliminate that vegetative growth and attempt to induce the remaining buds, auxiliary buds. But when we're seeing 80% or more growth, that's very difficult. But if it's not that high, that vegetative growth is not so excessive, you can eliminate it and continue applying nitrates because it had matured. So you'd have to eliminate the younger ones and continue to work with nitrates. We have a lot of other questions, but we're going to take one more. What impact could a post-harvest pruning do on later flowering? Well, I don't know how late you're talking about, but I have experience with medium and late term pruning. For me, early pruning means just after harvest. If I wait a month or a month and a half after the harvest, then I'm going to delay flowering, not just delay flowering, but I will see fewer flowers and less production. But what we see is that the quantity of fruit produced or the fruit produced is of better quality and larger. And delaying meant better prices. So this was much better than early pruning. If the pruning is done very, very late, we could inhibit flowering. So it's important to be very careful with this and what we mean, define what we mean by late. Great. And I have a message from Francisco Seva. He says, this is a very productive and interesting presentation. Congratulations. And Cesar Aborio, thank you very much for this very important presentation regarding high temperatures and also the different strategies. Thank you very much again. Dr. Pérez Barraza. We hope you will join us for future webinars of the National Mango Board. Our next webinar will be Efficient, Sustainable Weed Management in Mango Production. During this webinar, we will talk about options available for managing weeds in mango production, focusing on alternative chemical strategies and non-chemical strategies that are effective and sustainable. This webinar will be in English with Spanish interpretation with Dr. Ram Das Kanaseri, May 29th of 2025 at 3 p.m. Eastern Time. Thank you very much, Dr. Perez Barraza. Thank you very much, and good afternoon to everyone.